Hello and welcome, and I'm delighted that you're joining us for this presentation in the continuing education series that we call Container University. I'm Kirk Harnack. Software containers are already the industry standard for performing microservices efficiently and reliably. Now, this technology is now widely adopted in online service applications, including financial payments processing, stock trading, B2B, business to business, and consumer shopping, and literally thousands of other critical applications. So here we are together for Container University 206. We call it Redundant Virtual Broadcast Systems for backup, for work sharing, and for disaster recovery. Now, we broadcasters share a common goal of staying on the air, and now we have cost-effective failover and disaster recovery strategies available in the form of virtualized broadcast infrastructure. Wow, that's a mouthful. Even more, though, these strategies can actually be cross-functional, providing multiple benefits from a single, well-considered plan. Now, stay with me on this. We're going to consider how to think about redundancy to fulfill our need for business continuity. We'll also see about enhancing our daily broadcast workflows and add on-demand capability. Now, these benefits support keeping us on the air to serve our audiences and, importantly, to produce more revenue. Now, there are a number of scenarios where containerized software can be invaluable to us as broadcasters. We're going to consider virtual broadcast systems for disaster recovery. And yeah, that's a real picture. That's my radio station, a part owner of KKHJ in American Samoa, and that was just after the tsunami hit and retreated. So yeah, that was a disaster. We're going to look at virtual broadcast systems for backup in case of equipment or system failures. And this is a bit different than disaster recovery. We'll compare on-premises backup to cloud-based backup, and we'll learn about high availability for fast failover. We'll also consider how newer virtual broadcast systems can serve several purposes at the same time. We're going to be hitting on that a lot, actually. They can add to existing studios in terms of expanded capabilities. They can act as backup systems to cover on-air failures. And these virtual broadcast systems can even fully replace existing hardware-based studios, if that would be your goal. Now, Jake Alderman is our Virtual Solutions Program Manager. His work involves making the technology we're about to describe actually accessible to broadcasters and broadcast engineers, as well as to IT technicians. Alex Roman is Chief Technology Officer at MediaCo New York City Radio. He's responsible for Top 5 station WBLS FM, as well as Hot 97, that's WQHT FM, and legendary AM station in New York, WLIB. Alex sets the course for MediaCo's adoption of new technologies. And Sean Dolan is a partner at Inrush Broadcast Services. Inrush provides turnkey project management solutions consulting, and outsourced engineering support to respected media creators across the U.S. Now, Sean himself is highly experienced in setting up virtual broadcast infrastructure, both on-premises and in cloud environments, and in getting those systems to work together as part of a normal broadcast workflow. The biggest risk that we see now is actually business interruption. A broadcaster being off the air is like an airline with a broken airplane. Unhappy customers and no revenue. Plus, we now have additional risk factors that a couple of years ago we didn't know about, didn't recognize. And those would be pandemic, resulting in lockout of your facilities, and add these risks to a list of existing perils like natural disasters, fire, or any threat that threatens the occupancy of your building, like local police action or a shooter or who knows what, something that would keep you from using your facilities to produce radio. When a radio station, over the air, or their web stream is off, people are going to tune away. And all those hard-won listeners are gone, perhaps in minutes or even less. And some may never tune back in as they find other sources of entertainment or information that are available right now. And that's why business interruption can be significant, even if it's just for a few minutes. Here's Sean Dolan.
Right. Yeah. Business interruption is absolutely the dirty word at this point. And what's great is that there are other areas of, especially larger companies or larger broadcasters, that can help with that. So software-based architectures, for example, especially container-based architectures or software that can run in the cloud or in a centralized data center. It just so happens that many broadcasters already have information technology departments that have company systems running in such cloud or centralized data centers that already have redundancy built in. And more than that, the broadcasters themselves have staff on hand that know how to build redundant systems, that know how to build for reliability in the cloud. And so what's great is to be able to essentially step into that world and take some of these broadcast specific solutions, these broadcast software solutions that are purpose built workflow wise for broadcasters, and essentially put them in that environment, then be able to collaborate and work with some of these reliability engineers and other software or network engineers that are really skilled in making high availability systems. So not only do you get to bring your broadcast engineering experience as an engineer, like you mentioned, making sure the station's on the air, that sort of heritage of reliability that broadcast radio, broadcast TV has always upheld. You can still bring that to the table and bring that knowledge of broadcast-specific workflows and software and vendors, and find a way to collaborate with the information technology team, as oftentimes, unfortunately, the broadcast engineering team shrinks or dwindles.
The pandemic taught us that we need to be ready with operational models other than, hey, everybody just meet at the radio station every day. Here's Alex Roman to chat about how it's been affecting their operations.
As we've seen over the last couple of years, our world has been changing, and it does not have to be and probably should not be as tied down to a single location as it was in the past. We're able to place functions of our broadcast environment either in the cloud or at places like our transmitter site or at talent's homes. We have the ability essentially to be less tied to geography because we're not devoted to single purpose hardware that we have to buy a unit of every time that we want to put it somewhere. So one of my thoughts is you should be able to replicate your entire radio station at your transmitter site as a minimum DR platform. You could have a telephone system, consoles, codecs, and then again, your automation platform, all in a simple virtualized server off-site, and be able to run your entire radio station over a remote connection without your studio plant needing to be online for that purpose. That's one example. Or again, cloud operations. AWS is very common in our operations these days. I'm building a lot of things in AWS that lets us have an environment where we can essentially just spin up as much of a system as we need at one point in time and then turn it off when we're done with it. So we've done that on a number of projects already.
Now, during the pandemic, most broadcasters went to remote access operations. Talent, working from home, typically accessed existing studio gear. From home, they could remote control some or most of the things that they needed, and they could get their voices, either recorded or live, from home to the studios. A few stations moved their automation playout systems directly to, let's say, their transmitter sites, and a few more created a workable broadcast system in a cloud computing environment, eliminating the need for their brick and mortar studios. And even though these solutions may not have been perfect, they did point out the undeniable fact that we could create great radio using workflows that are different than what we've been used to. In New York City, Alex Roman reports that virtualization is becoming an important part of his station's infrastructure already. Indeed, it's becoming key to reliable and yet flexible operations.
Well, we've always had virtualization in our plants for the last couple of years at least, particularly our automation systems, and I see it as an expansion on that existing practice. We've gotten used to running the automation systems first in virtualization, then we started adding things onto them. So, for example, we've been virtualizing things like streamers. We've been virtualizing things like metadata management computers, things that used to be little 1RU PCs. That hardware is now gone. And now that we're comfortable with that and it's part of our regular practice, we're looking at the next step, which is ultimately how do we take what used to be dedicated purpose hardware for the broadcast environment that really underneath has always been computers running some sort of operating system anyway, and turn it into virtual appliances, whether it be a containerized system, whether it be a VM or something still running on Windows or Linux. We're able to do that within the infrastructure we already have and start bringing down the hardware counts. That leads to a lot of possibility.
At most stations now, we're still using purpose-built studio-based equipment, and that is, frankly, it's inflexible and unscalable. It does exactly what we bought it for, what we installed it for, but it doesn't do anything additional to that, and it does it only in the place that we put it. In other words, even with some remote control operations, we're still mostly dependent on this studio-bound hardware to get our audio played, mixed, processed, and delivered. This has been quite normal for the past 100 years or so of broadcasting. But a quick look at how we're getting to this point, or how we've gotten to this point of containerized software, is going to put into context what we'll be talking about in the rest of the webinar. Now, starting with the pre-virtualization scenario on the left, this is when we simply ran applications on an operating system. And we still do that today on our desktops, laptops, and mobile devices. However, in the early 2000s, multi-core CPUs made it possible to load up a physical computer with more work, and thus something called the hypervisor was born, allowing multiple operating systems to run on the same, more powerful hardware. Each of these guest operating systems can be Windows or Linux or something else if you need. Each operating system, however, requires the usual amount of patching and upgrading as we normally associate with complete operating systems. So as such, each operating system in a virtual machine environment does carry its own level of baggage. Containerized software was developed with the notion that a more lightweight environment would work just fine for each application. Only one underlying operating system is needed with containers, typically a Linux-based server environment, so you know it's very reliable. The container engine gives each container the attention and the resources it needs to do its designed job. Yet, the individual containers remain largely isolated from each other, so a problem with one of them won't degrade or stop the others. And that's one reason that containers are widely adopted right now in financial and transactional services. Containers are also highly manageable automatically for instant failover. Now, one could argue that radio broadcasters have been virtualizing actually since the early 1990s, when the first PC-based automation playout systems were installed and used on air. You may remember, if you're old enough, when we got our first PC playout systems, but we kept some cart machines and maybe a turntable in the control room, and just in case the PC locked up. Well, in this presentation, we're talking about virtualization in really a more modern context, and that is even virtualizing the very computing platforms that these broadcast systems run in. So we're talking about virtual machines and, even better, containerized software as the next level. Such systems represent the current technology, especially in terms of remote management, failover capability, and redundancy. Now, here are some examples of some of the broadcast functions that are available right now to deploy in software containers running on servers. You can get a full function audio mixer, and I mean full function, with audio processing on all the microphones, for example, and automatic mix minus on every single fader. Lots of modern features in a full function audio mixer that's totally software. Also, broadcast phone systems for talk shows, for news gathering, for IFB systems, and for contesting, as well as broadcast intercom systems for use in a local studio, a spread out production, or even all the way around the world. And these are just some of the systems that are available from Telos Alliance right now. More broadcast functionality is roadmapped, and features are being added to the existing ones as well. And moreover, other broadcast equipment manufacturers are committing to also containerized software infrastructure. By the way, all these containerized broadcast systems will run on server compute platforms, and that holds true whether it's on premises or in data centers or in cloud computing centers. So as with virtual machines on a server platform, different software containers can be installed on a single server, and that gives you multiple broadcast-related functions in one box, or spread across boxes, or spread across virtual boxes, as in a cloud computing environment. In this example, a Linux operating system is installed on a bare metal computer. And within Linux, we're going to install a container runtime engine, such as the Docker engine. Now, this Docker engine will then service and support the applications, the broadcast applications that we install in those containers. These are going to be audio consoles, again, phone systems, and intercom systems. And other functions such as audio processing, profanity delay, codecs, and more are becoming possible as well. Containerized software, of course, can interact with other software containers in the same computer or in the same data center or even in different data centers. So they can communicate with each other using audio over IP. So an Axia IQS virtual audio mixer, for example, can mix audio that's coming, say, from the playout system, along with external live microphone and even phone caller audio that may be coming from a Telos VXS instance in the same server. AOIP also allows external hardware, such as a Telos VSET talk show controller or intercom panels and other hands-on broadcast gear to interact with these containerized broadcast functions. So these containerized functions just fit right in to a fully containerized all software situation or a hybrid situation where you still have some hardware. So in this example, we see hardware broadcast equipment and containerized broadcast software, and they're both operating in the same physical plant. And except for the radio transmitter in that upper right-hand corner there, this broadcast gear is all in the same place, probably all on the same Axia AOIP LAN. Now, over the past 20 to 30 years, broadcasters have computerized a couple of key broadcast functions, right? Now, automation playout for on-air and maybe digital audio workstations for production purposes. We're not slitting tape anymore with razor blades. Fully virtualizing these computers leads to flexibility in their placement, their physical placement, and even in duplicating them easily. And it's a flexibility we haven't had before. Sean answers the question, why are we looking toward more broadcast virtualization right now?
There's a variety of reasons. I mean, one is the fact that broadcast facilities, the brick and mortar broadcast facility, is itself sort of a source of risk, right? So on the one hand, it's super expensive to have essentially two physical brick and mortar facilities that are fully redundant and identical. So if you have some sort of disaster or something in your area that disrupts the physical space that you're in, having two brick and mortar facilities, in the same city or something is not necessarily going to help you. Another example, right? The pandemic, it was regardless of physical location. At most you could have one person in each building, especially at the beginning of the pandemic, right? So, having multiple physical spaces with physical equipment in them doesn't always pan out. The other, zooming out even further, as engineers, we've always been learning new things. Broadcast technology has continued to change, and there's always been the next thing, the next iteration, the next sort of jump. So looking at software-based architectures, looking at running things in a private data center or in the cloud, but not so much relying on physical hardware that has a single purpose that gets racked up. That's really the next step. And to remain competitive in our industry, to be on the forefront of new technology and to deliver what our companies are expecting of us. We need to be able to use new technology in a way that benefits the business, and there's a good business case for using technology in this way to keep broadcasts on the air, no matter where folks are physically, no matter how physical equipment fails, or if a brick and mortar broadcast facility is unavailable entirely. So software-based architectures provide a really solid way to do that. And, broadcast vendors are becoming more and more apt at providing these solutions and providing the support and training and help needed to get these systems up and running with the reliability that folks expect from broadcast engineers.
As we look to convert some or all of our broadcasting infrastructure into virtual or containerized software systems, we'll typically think of having these new virtualized systems also on premises. After all, we already own or lease the building space, and we're just upgrading the broadcast functionality that we already have. However, if we're starting with a clean slate, or maybe we're downsizing our building requirements, or we'd like to have backup or disaster recovery infrastructure that's off premises, then we need to consider off-site broadcast infrastructure. Now, when going off-site, we're going to be considering the services of a private data center or one of the public cloud computing platforms available, like Amazon Web Services or Microsoft Azure or Google Cloud. Jake Alderman, in his role at Telos Alliance, does work directly with leading broadcasters in matching their needs and expectations with our containerized audio infrastructure software. Jake reminds us that broadcasters actually have always developed strong capabilities for disaster recovery.
The broadcast industry, was has been involved in disaster recovery since its infancy. We've been trying to build systems that can easily be brought back from a failure. We've embraced the idea of, making sure there's a playout machine, for example, placed out at our transmitter site that has a file share that's connected back to the office, so that if something happens at the main studio site where all of our playout servers live, we can still ship audio out to the transmitter site and be able to play music and breaks and commercials from the transmitter site directly to air. People have been doing those types of actions for a long time. And, before we had playout machines, you made sure there was a cart machine out there and some duplicate carts for the really critical air workflows. The broadcast industry has been a part of making sure that we can recover from a real disaster like a loss of power, a flood, another catastrophic event quickly.
Hands down, the simplest way to full redundancy is to simply purchase and install 2 of everything, right? This approach may be okay if we're talking about running shoes or a second set of car keys. It's not so practical if we're thinking about a whole radio station operation. Can you imagine? Hey, the transmitter quit working over here, so everybody get in your cars and let's crank things up at the duplicate facility down the road. Well, at some point of facility duplication, this concept does seem to go overboard. Now, there are times, granted, when a full duplicate is worth the time, the trouble, and the expense. For example, skydivers. They always jump with a main and a reserve chute because, well, there's a lot at stake. Though broadcasting isn't exactly a life or death proposition, normally, it's wise and perhaps financially crucial to have backup plans, or at least to have business continuity procedures that work for you. Since the early days of broadcasting, we've indeed had the ability, if not the budget, to simply duplicate every broadcast hardware system for full redundancy. But virtualization actually opens a better approach to full redundancy.
Mentally, it's very simple to handle. If you have 2 of everything, if you have one rack next to each other, a main air chain and a backup air chain. If you have a main air studio and a backup air studio mirroring each other, as is literally the case in a lot of broadcast facilities built years ago, it's very mentally simple because you can flip a switch and be over to your backup. But the only reason that existed in the first place is because we didn't have the methods or the technology to do it any better, right? We had so much other complexity to worry about, and we had so many other systems that were purpose built, and often almost exclusively hardware-based products that were purpose built, single purpose units, and were not very flexible. But now, due to the opportunities we have with some of these software-based architectures, as well as some of the kind of economic pressures that are put on broadcasters and engineers to get essentially higher performance per dollar, the only really way to achieve some of these goals and expectations that are set out by the C-suite are to get software-based architectures in play that can serve multiple purposes. So, for example, serving the purpose of allowing folks to broadcast remotely via a software-based mixer that isn't tied to a physical control surface or even a physical room or even a physical facility, or a software-based phone system that can be accessed from anywhere in the world or anywhere in the country from any facility. It allows you to both let folks broadcast remotely from home, from multiple facilities without worrying about the physical real estate. It also serves as a backup that makes the physical studio facility less crucial to actually getting the product on the air.
Most broadcasters already have some kind of backup studio in case things go wrong with their main control rooms. These backup studios are typically also production rooms that are used daily anyway, so we're not dedicating expensive resources that would only be used in an emergency. And as long as we can reroute the audio to our air chain, streaming, and our transmitters from these backup studios, well, we're good for a certain level of redundancy. If we think we're pretty well covered because we have extra studios from which we can go on air, we've got to ask ourselves, are these studios really a good backup? Are they, they're probably fine to handle a local failure, like when someone spills coffee into a mixing console, or maybe trips a breaker with a vacuum cleaner. But what good will extra studios be when you can't use the building at all? And we've seen this happen, sadly, in the news. Is there a criminal loose in the area forcing evacuations or lockdowns? Is there other local disaster requiring evacuation? Is there fire in the building or next door? Is there an earthquake that makes everybody get out of the building? Tornado, hurricane. All these things obviously can cause a real interruption to having staff being able to get into and get out of and stay in studios. There are numerous approaches to implementing backup systems with the goal of disaster recovery. And some would call this, as we have, business continuity plans. A data center is likely to have reliability and backup systems in place that many broadcasters don't and frankly can't afford. Data centers are often located in geographical areas known for low risk of severe weather or earthquakes. All data centers have and maintain backup power systems, and they typically have several connections to the public internet over several different backbone providers. So broadcasters can leverage this reliability that other people handle to their advantage. There's a good chance that a broadcaster's billing system, for example, or your HR system is already off-site in one or more data centers, as well as payroll and, as we mentioned, human resources, other financial systems. Your streaming provider, for example, is probably not on-site at your place, but in a data center. And so these things are hosted off. Maybe your phone system, your business phone system, is hosted off-site. Well, now we can consider placing our on-air operational systems off-site as well, at least as a backup, and gaining the same advantages that we enjoy with these other systems. Now, some broadcasters tell us that they need disaster recovery systems to stay on the air during an emergency, and afterward. That's important. At the same time, many broadcasters need more program mixing and origination capacity, though maybe only temporarily for shows, for big events, for seasonal work, for extra ball games at the end of a sports season. Well, wouldn't it be great if we could get 2 or 3 different key benefits from our virtualized systems, even though maybe our original plan was just to get a virtual system for one purpose?
Certainly, you can use virtualized products to add capacity to your facility. So let's say you have a VX Classic, a product we started making about 10 years ago. There's constraints in that hardware platform of how many channels it can run of audio in and out and how many lines it can support for calls in and out. So if you've run out of capacity on your VX and you need to buy some extra additional capacity, you could buy our new VXS product, which is available as a container. And when you buy VXS as a container, you could look at integrating that into your facility for hybrid workflow. So let's say you add a couple more lines. Now that makes doing that podcast that needs a phone call on a regular basis a lot easier, because we're not trying to pick a line off of our VX Classic, which is limited, and we're able to use this new line we have spun up available to do that additional content. Also, you've made yourself potentially more able to handle a disaster. You've increased your capacity there for failure, because that VXS instance could be shifted in a hybrid workflow between the ground and the cloud, or your studio and a transmitter site. So if you had a server at your studio and a server at your transmitter site, you don't have to go out to the cloud. You can just do it between 2 places you own. You could have your failure system say, hey, this has lost itself over here for whatever reason that is, power, ISP outage, it doesn't matter. The orchestrator just sees the service outage and it brings that service up in another location.
What does on-premises container deployment look like? Well, for most broadcasters, it'll simply mean adding a server computer or 2 to the existing rack room. And then within that server, we're going to install 1 or more software containers to provide additional broadcast system functionality. Now, with extra software audio consoles, we can provide convenient, on-demand broadcast mixing, on-air phones, and other services. For example, we can add or replace consoles. If somebody needs to do their show from their desk, from their cubby, they certainly can using a software audio console. We can do on-air phones. We can do sports and holiday programming. We can do election coverage. You may need a lot more people on hand and mixing capability to handle different precincts, different elections. Lots. If you cover a large area. You're gonna need these kind of things to provide proper coverage. Maybe you've added some HD channels. Maybe that's where the election coverage or the sports is going to, and this will help you cover those things. Or maybe you want to add some additional paid programming and get another revenue stream just by adding a software audio console to help make all this kind of thing happen. Alex Roman looks at broadcast system virtualization as an approach to solve several problems and to actually improve workflow for talent.
No, I think virtualization is not just a DR tool, but it's a flexibility tool. It lets you add and subtract resources as you need them. We found a lot of the time that we're doing special projects, that we may do a stream for something or a program stream for a special purpose. And I don't want to have actual hardware sitting on standby, pre-built with automation, playout, or a stream encoder, et cetera. I want to build that as I need it and then delete it when I'm done with it, because these things have proven relatively easy to build. We've done this with both audio and video. There's a lot of recipes on AWS, for example, that make it very easy to deploy assets in the cloud and then just delete them out when you don't need them anymore.
By the way, near the end of this presentation, Alex Roman will have a couple of very practical and useful tips about getting the internet or other network connectivity you need at your broadcast location. Be sure to stay tuned for that, as Alex's advice is based on successful implementations in a couple of challenging areas. Now, every few years, our broadcasting business finds a technology that's pretty attractive for solving some problem. Back in the 1980s, we adopted ISDN digital phone calls to allow broadcasting from remote locations in very high quality and for a reasonable cost, certainly far cheaper than the satellite uplinking that was the way of doing it at the time. Audio over IP, or AOIP, well, that ushered in a new era of studio flexibility and convenience and audio quality and remote access to AOIP systems. And the combination of VoIP technology and AOIP brought us convenient and better sounding phone calls and intercom systems. Well, now software containerization is enabling broadcasters to virtualize our production and on-air systems. We're able to deploy any number of broadcast system functions and do it on premises, or if we choose, in data centers in diverse locations. What's more, these containerized software systems are deployed and managed using IT industry standard tools. Now, this lets broadcasters draw expertise from a huge pool of IT professionals. And this lowers the cost of this kind of incredible flexibility and power that we can now obtain. We know that audio and video entertainment is distributed using virtualized infrastructure. Netflix, for example, Pandora, Disney Plus, everyone. Now it's possible, and it's even practical, to produce audio and video content in real time using virtual broadcast-oriented systems, again, either on premises or even remotely. Virtualized systems running in ultra reliable and redundant hardened servers are accessible, by those who are authorized to use them from anywhere, so we can be secure. Thinking about this topic of getting more than you're planning on receiving, virtualizing your broadcast infrastructure for one or more purpose and getting other benefits are very close, is something that Alex Roman notes here.
Absolutely. I think that's, first off, always a temptation. You're going to find some way to use the tools that you've already built. You might have built it for a backup purpose, DR purpose, and then you realize that it gives you a lot of flexibility to do other things. What was supposedly your backup system at your transmitter site, well, now you can go and do a remote from the street somewhere using that system and perhaps take your studio offline for maintenance while you're doing that. Once you have it, you're going to start figuring out all kinds of good reasons that you never thought of in the first place as to why this is actually an indispensable tool to the modern broadcast facility.
Now's a good time to mention, please feel welcome to ask your questions as we go along. There is a Q&A button on your webinar interface, and we'll answer your questions privately, either in chat or by email. Should broadcasters put their virtualized systems at their existing studios or in the cloud? Big decisions for a lot of places, or maybe even at the transmitter site. Well, there's probably no single answer that's best for every broadcaster. Everybody's situation is different. Alex's high-profile stations in market number one suggest a dual approach.
Okay, well, I am a big proponent of the hybrid cloud workflow. I think that that's a really good solution for our industry. Part of it is sort of my old school broadcast engineer thought that I should be able to run as an island without outside utilities. So I always want to have my data and my playout systems available in my house, just in case someone goes and digs up all of the fiber in the street outside, for example. So I always try and have some of that stuff located in a virtual cluster on-prem. The other thing to think about is ingress and egress cost. As you push large amounts of data to the cloud, it not only costs money in terms of those costs, but it also costs time. Depending on what your bandwidth is, particularly moving video around, we found it's a very long replication time to take video that might be on a hard drive locally and send it to the cloud. So you might be doing two things at once. You might be pushing things off to the cloud while you're also using the local copy of that content to get quick turnaround on something you just created or just produced.
Broadcasters may choose to locate some of their broadcast infrastructure in a private data center. The physical security and environmental stability are certainly better than a broadcaster can provide in his own studio facility. And internet access in a private data center should be blazing fast and redundant as well. Because a broadcaster will have his own caged area with equipment racks, again, in a private data center, it's often permissible to install other professional yet non-server equipment. So you need to be thinking about this if this is the way you want to go. A broadcaster could, for example, install hardware audio codecs or audio processors, for example, if they aren't ready to virtualize every piece of broadcast gear just yet. Now, there would still be capital costs as the servers or other equipment are typically supplied by the customer, by the radio station. However, this practice varies from one data center to another. Some of the uses, well, I think they're pretty much the same as we saw before. This allows you more capacity to do sports and holiday programming, cover elections, add HD channels and provide programming that's worth listening to on those. And again, if you want to support paid programming, but also for disaster recovery, because we're talking about infrastructure that is off of your premises. It's in a place that's typically very secure, and you just need remote access to it to make it run. Now, what about public cloud services? How is this different, like Amazon Web Services? Well, this is attractive in many ways for hosting our broadcast infrastructure. These services are renowned for their reliability and their super redundant connectivity with the public internet. Geographic and even green energy options are interesting to some customers as well. Note that a broadcaster would never own or install his own server or other equipment in a public cloud data center. We only rent compute space. These are highly sophisticated and well-planned virtual servers designed by computer scientists and maintained by a fleet of tech professionals. Uptime is really everything for what they're selling, or should we say apparent uptime, because look, systems do fail, but automatic virtual failover is a normal feature of today's cloud computing services. Users are often unaware of any changes or failures. And note that customers, you and me, the engineers, we have no physical access to these public cloud data centers. All your work is done remotely through secure connections. And for broadcast functions, recorded audio files are easily transferred quickly in and out of our software containers. And live audio is possible too. It just takes proper configuration of the systems, both in the field and in the public cloud data center. We can also get live processed audio out of the cloud and to our transmitter sites or other destinations. There's examples of the compute platforms being in there and in your broadcast functionality. And example uses, again, same thing, sports and holiday programming, just additional content that you need to create. And again, there's revenue opportunities with some of these as well. And it's good for disaster recovery because it's out of your building. It's somewhere else that is presumably safer than what you can provide. Like I tell you, the whole world has a lot of experience with driving vehicles and the common disabling breakdowns that we get with those. Perhaps the most common breakdown would be a flat tire. Now, notwithstanding those expensive run flat tires, if your car suffers a flat tire, you won't be driving any farther until the faulty tire is replaced. And while flat tires are not uncommon, it is pretty rare to have more than one flat tire at the same time. While multiple simultaneous tire failures could maybe occur, it's not very likely, and carrying replacements for all four tires wherever you drive would be pretty impractical. So we plan for the most likely failure scenarios. And that's why most automobiles are equipped with one and only one spare tire. Indeed, these days, that spare tire is typically a temporary tire intended to work only well enough to get you to a service station or a tire store. The common automobile spare tire is an example of what we call N+1 redundancy. N+1 works pretty well for spare tires. And what does that look like for virtualized, not hardware, but virtualized broadcast infrastructure? Sean?
The first experience a lot of broadcasters had with N+1 systems, or at least a lot of engineers had with N+1 systems, were with transmitters, right? Where previously, it was back in the day, you couldn't just retune your exciter to operate on a different frequency. So every station, especially in major markets, where revenue affecting events were not really tolerable. You have a main transmitter and a backup transmitter sitting often side by side in the same site. And if you have multiple stations at that site, you have a main and a backup for every single station. But now, again, with some of the advances we've made in technology, and of course now a frequency agile exciter is standard. So instead of having, if you have 5 stations at a single site, which is more common now because of consolidation of resources, you just can have a single backup transmitter, because what are the odds that 2 of your transmitters are going to fail at the same time? It's possible, but extremely unlikely. And as we think about the sort of business case and economic impact that having a double of everything might have, and the difficulty of selling such a concept to the folks upstairs, having a single system that is available in terms of our conversation in the cloud or in a private data center that can back up physical hardware is really the name of the game. So having this N+1 type system is a good way to have reliability and bring the history of reliability into the software world, while saving costs, while maintaining the broadcast product as you expect it to be.
So that's N+1 redundancy. As we learn about the lingo and options surrounding broadcast system virtualization and containerized software, we're going to hear a term, high availability. And what exactly do we mean by high availability? Well, it protects companies from lost revenue when access to their data resources and critical business applications is disrupted. And what kind of outage is your business trying to protect itself against? Planned outages, such as backup of Windows operating systems, or maintenance, or unplanned outages, should be considered when you're thinking about, do I need high availability in the cloud? Do broadcasters need to implement high availability systems? Well, that's really up to each broadcaster, but it isn't just another facet of virtualized and containerized systems. By the way, containerization makes high availability a lot easier. This high availability is supported by a variety of software monitoring and management tools. However, it's often characterized by a comparison of pets versus cattle. You're going to remember this little talk from Jake Alderman. What does that mean, Jake?
The tools we use to create a high availability environment depend on the technology you're using to deploy software products. So, VMware has a suite of tools that help make their systems highly available. So you would use, if you're a VMware shop, you would use the VMware set of tools. If you're in a Proxmox environment for VMs, there's a whole different set of tools that Proxmox brings to the table. The one tool that is sort of emerging lately as the big trend that people bring up as part of talking about high availability is Kubernetes, or K8s is another way it's written. It's a capital letter K, the numeral 8 with an apostrophe S. But Kubernetes is another tool that's becoming part of this high availability infrastructure. The big piece that you need to accomplish when you're working in high availability is that you need to have observability into what's happening with those applications and the platforms that are running them. So whether it's a platform fault or whether it's an application layer fault, you can see that a fault has occurred, and when it occurs, trash it and bring a new instance online. This is commonly referred to as treating devices as cattle instead of pets. We care about Fluffy the dog. Fluffy the dog is our friend. He rides in the truck with us home from the transmitter site. We don't care about cattle, right? Cattle get a number tag in their ear and they're here to serve a purpose. We raise them up and we take them off and sell them to a meat processing plant, right? Because they feed us. So that's the delta between cattle versus pets. We want our infrastructure to be cattle, not pets. We don't want to have to care so much where an instance is running or how it's running. That's the key foundation of high availability. The tool stack varies a little bit depending on exactly what platforms you're running on and whether you're doing things in certain ways. But all the major vendors have different tools available, and the one that's sort of coming to the front as the glue amongst even proprietary vendor tools is Kubernetes.
A lot of this webinar series has been focused on technologies that broadcast engineers frankly, we're not too familiar with. Software containers are new to us, and they're different from regular software applications. We get that. Indeed, we at Telos Alliance have had to start learning about software containers just as you are doing now. As a broadcast engineer himself, Sean Dolan promises that this learning curve is worth it.
anything important, anything impactful, anything significant, anything revolutionary always has a learning curve, as we know. So bringing redundant systems into the conversation early and adopting software to do that early on in the process is really the way to go. Oftentimes this software, because it's so powerful and so configurable, and because the environment it's running in is also so flexible. It's not just a Windows installer where you can hit next, 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 finish, and now you have something running in the cloud. Sometimes it's often close to that, but there's always little tweaks that need to be made, and not to mention training staff, getting access set up, network security, things like that. So I think what's most important for folks who are looking to adopt or look into adopting software-based architectures for broadcast is to step into it slowly, but do it early. Adopting some of these systems early, getting a mixer running in software, getting a phone system running in software, or an intercom, or a processor, or a stream encoder running in software early is great, because it affords you the opportunity to learn more about the system at your pace, not do it under immense pressure, because when the time comes to actually use it, you'll know it works, and you won't have to worry about learning all of this stuff in a very short period of time. You won't be caught off guard. You'll be ahead of it. That'll not only be great for your broadcast, but also be great for you personally as an engineer.
Another indication that broadcasters and content creators are moving toward virtual machines and containerized software in cloud computing. Amazon Web Services, AWS, is offering training in cloud systems that cater to our needs. Indeed, AWS had a large booth at this spring 2022 NAB show in Las Vegas, with, frankly, standing room only crowds there.
I think that that's a really good sign for us. And AWS is not just showing the broadcast industry an interest, they're truly developing around it. You look at the AWS Elemental video stream encoder and some of the other tools that they have around that, they are building tools that are specifically for broadcasters because they see a market here. And it's not just new media that they're looking at. They are looking at traditional broadcasters and saying, hey, we have workflows for you that match the way that people want to work today. Being able to do hybrid cloud editing and video storage and streaming direct out of the cloud. I think it's a really great sign for our industry that they are actually presenting these tools for us and investing all the effort and money into developing them.
Other industries have been virtualizing with software containers for a few years, as we mentioned at the beginning of this webinar. Think of all the business, entertainment, education, and such that we can do online these days. Is the broadcast industry on track with other industries to leverage these same technologies and approaches?
Other industries have obviously used software to get their business goals completed, for years. And broadcasters have been doing the same to a large extent, right? A lot of the hardware boxes that we buy are little computers running software, right? At the end of the day, as much as folks don't sometimes want to think about it, that's been the case for years. We all love to have our physical studios that are well apportioned and customized for each talent or show that comes in. And it's not to say that we can't have that, but we can just accomplish it in different ways. We can use software to set up your console how it's needed. We can use software to set up branding on video walls around the studio. So it doesn't really matter which room you step into. It becomes yours. The only difference is it might smell a little better or a little worse depending on who was in there before. But even more than that, being able to use software to broadcast means that the physical space is less important, and it really allows future growth in this area to continue. So I'd say, when you're building a new facility, you're considering upgrades to your current facility. I think this is the number one thing folks should be thinking about is how can I build software-based architectures? How can I bake that into my core infrastructure so that as this area grows, which it will continue to, and the demand will continue to grow as well, and the expectations will even more, you'll be set up for success.
It seems that too frequently we need high bandwidth data connections in places that may be out of reach from the usual internet providers. And this happens frequently, of course, with rural transmitter sites, but it also occurs with offices and studios that may be on the edge of town, for example, where service hasn't been built out yet. Other engineers have solved this problem quite well, and I promised you earlier in the webinar that Alex Roman would be back with a couple of really good tips that are worth taking note of. And here's the first of those. Alex?
we've learned as an industry that we can move very high-speed data around through the air. So if you have a problem with the last mile, figure out a way to bypass it. If there's only one ISP available in your building and nobody else will come and do a fiber run to it, well, you can just do a 5.8 gigahertz or 11 gig or 23 gig shot to wherever point of presence of a service provider is. There are wireless ISPs in a lot of places where they don't have a lot of very good facilities-based internet service providers. There tend to be a few wireless ISPs operating that do run pretty good networks. And then learning how to use routers to spread your service across multiple service providers so that the backup is seamless. That's a very important skill to have. I think that there's usually a way to work around that. I mean, I understand that people may be in this situation where all they have is a single cable modem, and truly it may not be very reliable, but I think that you can find a way to get egress out to another provider with just a little creativity and some effort on your part.
Now, whether broadcast system virtualization is deployed on premises or in the cloud, good, reliable connectivity is honestly key to successful operations. We've got to have that. We hear from engineers or business managers who tell us that they've been unable to get reliable internet service at a given location, or they can only get one provider whose service isn't up to par. Alex Roman asked if he could leave us all with this tip for getting one or for getting several internet providers into your facility.
So we found that carriers are sometimes willing to build out into a building. Sometimes it depends on a service commitment that you are willing to make. For example, if you're willing to make a 2 or 3 year deal on a circuit, they will see enough reason to pay for the build out costs and just get it done. The other thing that we've been really successful with doing is working through telecom brokers. So when I'm looking for bandwidth and for circuits, I don't call the carriers directly. I have a broker that I use. I tell them the endpoints and the speeds I need, and they will reach out to every carrier that operates in the area and get the monthly cost and any one-time costs. And they know the right people at these carriers to call who are willing to compute the build-out costs and to generally make an offer to do the build-out. We found that in buildings that we considered underserved, a broker is generally able to find a couple of carriers that are willing to serve it.
So what have we learned over the past 54 minutes or so? Broadcasters can now have full or substantial redundancy of their hardware broadcast systems. They can do this on premises in their own servers running containerized software. Can do it in a data center, again, using a containerized software, or in public cloud space like Amazon Web Services. And you can get just the amount of redundancy that you want. You can use it just when you want, and you can use it for more purposes than just disaster recovery. You can use it for pretty quick or instant backup, and you can use it for expanded capacity if you've got financial opportunities to produce more content. This redundancy can be rationalized for one benefit, yet it can deliver several benefits. So I just want to drive that home. Do it for disaster recovery, or do it for backup, or do it for the expanded capability that maybe you need, or even do it so that other employees can easily reach into the system, whereas it's kind of hard to build that into your studio operation. Cloud-based systems are going to naturally be designed for different people to access them and work together. So we have these other capabilities that come along when you do it for whatever your given reason is. And software containers, this is key, software containers are the enabling technology for effective virtualization of broadcast systems. Broadcast functions in software containers are ultimately deployable. They almost don't care. I'm not going to say they don't care what server they're running in, but servers have become very generic. They need to be. They need to be able to run anybody's software. So they're very, very deployable. They're very manageable with the tools that Jake was talking about earlier, Kubernetes or other provider-specific tools. They're very manageable, and they're also very efficient. You get a lot of computing power with very little overhead when you are using software containers, which is why they were invented. All right, that's the end of Container University 206. Our next one, I think we're going to call it 301. I hope I got the numbering right, because it's going to be more of a practicum. It'll be a hands-on. We're going to actually show you systems that are up and running and passing audio. And I'm not sure, I don't think we own a transmitter. I'm not sure we're licensed for a transmitter, so we're not going to be broadcasting anywhere, but we will show you how that audio can get around, get mixed, get manipulated, get processed, and get put out to where it needs to go, whether it's on premises, in a data center, or in public cloud space. And that, my friends, is Container University 206. I'm delighted that you have joined us for that. And Lindsay, I'll turn it back over to you.
Awesome. Thank you so much, Kirk, for taking us through that webinar. And a huge thanks to Alex, Sean, and Jake for all their efforts and being a part of this webinar as well. Our Q&A team was able to answer all of the questions that came in throughout the webinar. So I will leave you all with this. We would appreciate just a few more moments of your time. If you wouldn't mind filling out the survey that will pop up on your screen once I close this webinar. We really appreciate the feedback. While we're not asking if you like or do not like Kirk's puns, we still would appreciate you to fill out that survey and appreciate you spending the time with us today. So until next time, thank you, everybody. Appreciate it. Have a great one.
Thank you, Lindsay. Thanks, Kirk.
Thank you
Bye
all.
all.
Bye,
Thanks, Kirk.
everybody.